All right, so ChemQuest over an Electron's address. Information, energy levels, and sublevels. So, talking about the Bohr solar system model, as you remember, the electrons are located in energy levels. In real life, the current model of the atom isn't as simple as that. There are things called sublevels. Sublevels are located inside the energy levels, just like subdivisions inside of a city. Each sublevel is given a name. Here's the following table, and this is important. First energy level S, second energy level have S and P sublevels, third energy level have S, P, and D sublevels, and the fourth energy level is S, P, D, and F sublevels. Important information. Now, something to note, if we're in the second energy level, there's no such thing as a D sublevel, only S and Ps, because there are only S and P sublevels inside there, okay? So the energy levels will tell us that. So let's talk about a couple of things that we can go along with this, all right, using this chart. So first question, how many sublevels exist in the first energy level? Well, there's just the S, so therefore there's only one. How many sublevels exist in the second energy level? S and P, therefore there are just two. How many sublevels exist in the third energy level? S, P, and D, which will be 3. Now, how many sublevels would you expect to exist in the fifth energy level? Well, if it follows suit, we would expect 5, but there are only 4. So even though we expect 5, there are only 4. S, P, D, and F goes beyond the fourth energy level into the fifth energy level. Now, does the 3F sublevel exist? So I look at third energy level, S, P, and D, there is no F, so the answer is no, it does not. So we can have a 1S, we can have a 2S and a 2P, we can have a 3S, 3P, 3D, and we can have a 4S, 4P, 4D, and 4F. And that's where we stop, okay? So now, let's talk about orbitals. So far we have learned that inside energy levels, there are different sublevels. Now we'll look at orbitals, okay? So orbitals are inside of sublevels. And the comparison is just like streets that are inside subdivisions. Different sublevels have different number of orbitals. So you can see a sublevel S has 1 orbital, P has 3, D has 5, F has 7. Now here's the fact. Only 2 electrons can fit in each orbital, okay? So in an s orbital, you can have a max of 2 electrons, all right? In a d orbital, you can have a max of 2 electrons. So in any orbital, there can only be 2 electrons. But since a d sublevel has 5 orbitals, and each orbital can have 2 electrons, then a d sublevel can contain 10 electrons. So that hopefully helps you understand the difference between sublevel and orbitals, or at least gives you something to hang your hat on with that, okay? So we're going to do something here. I'm going to add another table to this. And we're going to talk about total electrons. So if I have S sublevel with 1 orbital, each orbital contains 2. If I take 1 times 2, that equals 2 total electrons. All right? So now let's look here. In the p sublevel, I have 3 orbitals with 2 electrons per orbital. Gives me a total of 6 electrons. I think you see where I'm coming here. So in the d sublevel, I have 5 orbitals with 2 electrons per orbital. Gives me a total of 10 electrons in the d orbital. And then our last item up here is the F sublevel. And the F sublevel, there are 7 orbitals, 2 electrons per orbital for a total of 14 electrons. So the S sublevel has 2 total electrons. P can hold 6, D can hold 10, F can hold 14. That chart's helpful for as we do things later. So how many orbitals are in the P sublevel? P sublevel has 3 orbitals, so I would say 3. How many orbitals are in the D sublevel? D sublevel has 5 orbitals. Now, how many total sublevels can be found in the entire second energy level? Now, this requires me to go up here. And in the second energy level, I can have S and P. So I got to see, it's S and P sublevels. So how many sublevels are there? There's S and P. That means there's 2. How many total orbitals would be in the second energy level? Well, if there's S and P sublevels, then I have 1 and 3. I have 4 orbitals in the entire second energy level. How many electrons fit in an F sublevel? F sublevel, 7 orbitals times 2, 14. We did that math already. How many electrons can fit in an F orbital? Each orbital only holds 2 electrons. 10. How many electrons can fit in a d orbital, a p orbital, or in any kind of orbital? Every orbital holds 2. So what's the difference between a sublevel and an orbital? I mean, I'll let you come up with that answer, but put something that helps you understand the difference between them. So now, how many electrons can fit in each of the following energy levels? Well, energy level 1 contains just S sublevel. So S sublevel has 2 total electrons. So then the first energy level, 2. Second energy level has S and P, S1, P3 for a total of 4 orbitals. 4 orbitals gives me 2 and 6, 8 total electrons. Third energy level has S, P, and D. 2 plus 6 plus 10 equals 18. And then my fourth energy level has all 4 sublevels. So I got to go 2 plus 6 plus 10 plus 14. 24, 30, 32 total electrons. So that gives us an idea of what can fit where, okay? Now, how we represent this. So we write an address, if you will, for the electron. It's a shorthand notation, and here's the diagram that can tell us that. So we have a 3, a P, we have 3 lines and an arrow, okay? So first off, the arrow is an electron. Since it's pointed upwards, that means it is spinning clockwise, okay? 3P means that it's the P sublevel in the third energy level. So first number is energy level, the letter is the sublevel, and then each of the lines, right, each blank is considered an orbital. And since P has 3 orbitals, and we know that because of here, P has 3 orbitals, my P will have 3 lines after it. And in the diagram, the electron is the first in the first of the 3 P orbitals. So there's my arrow, there's my electron that's spinning clockwise. So this is how I talk about 3P with 1 electron. Now here's another example, 4D with that. So let's look at this example. Why are there 5 lines drawn next to the D? Well, a D sublevel has 5 orbitals. So therefore, we know that the 5 lines, because the D sublevel has 5 orbitals. In example 2, what does it mean to have the arrow pointing down? That just means, if up means clockwise spin, down must be counterclockwise spin. So the electron is spinning counterclockwise. So now the notation for a 2s orbital spinning clockwise. So I put 2 in S. S has 1 orbital, so I just have 1 line after it, all right? And then I put the arrow pointing upwards because it is spinning clockwise. Okay, the notation for an electron in the first energy level spinning clockwise. So first energy level, and remember the first energy level only contains s orbitals. So knowing that, I know I have our s sublevel, which will mean 1 orbital. So I have 1s with 1 line with 1 arrow pointing upwards because I'm spinning clockwise. Looking at this notation, what's wrong? You should find 2 things. So let's look. 2D, 4 lines, and arrow pointing downward. Okay, arrow pointing downward could be counterclockwise spin, so that's not wrong. So the D, should the D have 5 orbitals? Let's look, or 4 orbitals. And the answer is no, the D should have 5 orbitals. So this is wrong because this D should have 5 lines. So the first thing wrong, it is missing an orbital. Okay. And then the second thing wrong 2 and D. So let's look at energy level 2. Energy level 2 can hold S and P, but not D. So therefore, not only does it not have the right number of lines, but we can say that the second energy level won't have a D sublevel. Okay, so those are the two things that are wrong with that picture. And then lastly, here's the notation for a fourth energy level if an S sublevel is spinning clockwise. Fourth energy level, F sublevel. F, as we recall, has 7 possible orbitals, so I have to have 7 lines, and it's spinning clockwise, so I just put it right there and say it's an upward arrow. This information, especially these charts, is going to be useful. This is your first page of notes on this stuff.